Hi, this is Carlos, and this is a short demonstration of my mini research project on Grad-CAM for CNN interpretability. Now, the idea behind this Grad-CAM is to visualize which parts of an image a convolutional neural network uses to make a prediction. This usually helps us understand and debug deep learning models that normally act as black boxes. So when a learning module makes a prediction, we don't really know what it's using to make that prediction. We just get a prediction if it's either right or wrong, but we don't know exactly what areas it's using to make that prediction. So the idea behind this mini research project is to use a heat map to see what areas the neural network is using to make a correct or incorrect prediction, and that way we can modify the learning model and make adjustments so that it can use the correct areas. Now for this specifically, I'm using a pre-trained ResNet 50 model from PyTorch. This is already installed as a library in these modules here. So this is ResNet. Here I labeled the class as the Grad-CAM, where we're loading the model. And the pre-trained ResNet is over here. It's already loaded as a model as well. So this has already been loaded in the module. And this is the whole script. And it's running the script on a sample image. So I have loaded here a couple of stock photos already on my files. And we can change the file name based on what we want to determine or create a heat map for that image. So for example, I have my dog here, but we can change this to a stock dog, and then we can run the sample, which I will show in a second. But yeah, so this is, let's see, so let's open that image now. And this is the image that we have loaded. So we already have the input image. It's also in the files. We already input the image path here. And it could be pretty much any image. We'll show multiple examples in a second. But it'll load an input image. And basically what this does is we can load the class and it'll give us a cam shape. And this module will generate the heat map. So it will generate actually 3 photos. It will regenerate the original photo, and it'll regenerate a heat map based on the original photo. So the heat map is telling us the areas that the neural network is using to make a prediction, and an overlay, which it does the original image plus the heat map added over, and we can tell based on the original image what areas it's using. So here in this stock image, it should be a pretty easy determination. And I used the dog because we've been using dogs examples in these past lectures to kind of highlight the examples of prediction and neural network interpretability. But here we have a stock image of a dog from Google, and we can see also the Grad-CAM heat map. So this is what's telling us is this area, it's what's being used as from the original photo to make a determination of what it is or make a prediction. It won't tell us exactly what prediction it made, but it does tell us what areas it's using. So for example, if the red areas was to the left of the dog right here, and our neural network was telling us that this is a tree, we would actually know exactly where the heat map is and what areas it's using to make that determination. It's a little bit easier to see with the overlay, so we see that it's using the tongue, the snout, the eyes, the ears, and a little bit of the shape of the dog. So we can tell based on this heat map that it is using the correct area that we wanted to use. Now we'll try it with another preloaded image. We will change the file name to the car. This is just a stock car from Google as well. We'll load the image. This is our input image. We'll load the cam shape. And we'll load also the original heat map and the overlay. So it'll take just a second here. There we go. So original, as you can see, it is also making the correct determination. We can tell that the neural network is using the correct area. So it is looking at the tires, it's looking at the It's looking at the lights, looking at the overall shape of the car. So we know, okay, well, this is the correct area that we want the learning module to be looking at. Now we'll try another image. Usually Google images are pretty easy to determine. I have loaded an image of my dog here, personal dog, and we'll input as an image. So the good thing about this is that we can tell once we look at the heat map if it is looking at the correct area. So we wanted to see, the dog's face, some of the dog's shape, and there's a couple things that can throw off I guess the neural network here. There's a couple shoes there, some things in the background, there's a couch. You can't really see the dog's ears. There's a couple things here. So there's numbers as well. So if the neural network doesn't make a correct determination, we can see what area it's looking at and try to train it so that it actually. So here we have the cam. We're going to load the cam. And we have the original image, the Grad-CAM heat map, and also the overlay. So yes, it is looking at the correct area. This is the area that we want the neural network to be focusing on. Now we have another example. This is a abstract image, so we cannot really tell what there is in the image. And there's actually it's a caption there that name one thing in this photo, and I don't think anyone can name anything in this photo. So there's a bunch of things. We don't know exactly what this is, but it's interesting to see what the heat map says of what the neural network is trying to look at to make a determination or a prediction. So we'll run the same thing. And in this case, what it's telling us is the neural network is looking at this area. So it's trying to make a determination of whatever this is. And that's where we can tell if we input an image like this on one of these prediction models, where we input an image and it tells us that this is a duck, for example, we can tell exactly what it's looking at to make that determination. So just a little example of how we can use heat maps and Grad-CAMs to debug and learn what these modules are looking at to make a determination.